All right, in today's video reference section 7.3, we're going to learn how to solve linear systems, a new method, and this new method is basically the elimination method. And we're going to start with just adding and subtracting the two equations. Now, before you start technically any of these steps, you have to make sure your two equations are in standard form. So copy this down. So when you can someone tell me what standard form looked like from previous chapters? Yeah, ax plus by equals c. Technically, it doesn't have to be standard form, but we just like to keep it all on the same page. But really, the equations just need to line up with the like terms. Okay, so you'll see what I mean when we do an example here. So basically, the first step in these examples is to add or subtract the equations, and this will work because today's examples you'll be able to eliminate one of the variables from the system, and then you're going to solve the resulting equation for the other variable. And then just like before in substitution, you're going to back sub it into the one of the original equations to find the eliminated variable. So this time it literally is going back into one of the original equations, not any revised equations. So let's do a couple of examples here. Let's look at here, example 1. And you can see this one is addition. So looking at the way these are lined up here, can someone tell me what variable, and when I say add the equations, it's literally like adding when you're in elementary school, just adding straight down. So if you were to add like that, make an addition problem out of these two equations, can someone tell me which variable will eliminate, the x's or the y's? Yeah, it's definitely going to be the x's because 2x plus negative 2x is eliminated. So you're left with 8y equals 24, and then y must equal 3. So this is going to be what I'm going to use to back sub into one of my equations. I'll just choose the first equation here. So can someone tell me what that looks like when it's substituted? 3 times 3 equals 11. And so you're left with 2x plus 9 equals 11. And you're left with, sorry, my pencil keeps breaking here. You're left with x equals 1. So you would write the solution how as a coordinate? 1, 3. All right, let's do another one. This time it's going to be subtraction. Looking at these two equations, if you were to subtract it, can someone raise your hand and tell me what would eliminate here? Yeah, the y's. Believe it or not, you have to, when you subtract, when you have like 5 minus 10, you have to change to addition and change the sign. Well, that's kind of what you have to do with these. So you could really make these all, sorry, the paper's a little here. So you can make this negative, and this positive. So change all the signs and then really just add them. So you could subtract that way. Or you could just subtract the other traditionally, but this just makes it easier. So here you're left with negative x plus 0, or nothing because that eliminates, equals 4. So negative x equals 4. So then what would you do to both sides to solve for x? Divide by negative 1. You're left with x equals negative 4. So I'm going to back sub that into one of my originals. I'll be different this time and just back sub it into the second equation. So before I changed any of the positive and negatives, I'm left with 5 times negative 4 plus 3y equals negative 2. So then I'm left with negative 20. And then I plus 20 to both sides. And now I'm left with 3y equals 18. So y must be equal to 6. Raise your hand. Can someone write that as a coordinate for me? -4, 6. Great. And the last example here, before you try some on your own, you're going to have to rearrange the equations into like terms that line up. So I'll just try to put them both in standard form. So this first one looks like it's in standard form, so I'll just rewrite it. 8x minus 4y equals -4. And the second one, I'm going to bring the x to the other side. This term over here. So it'd be -3x plus 4y equals 14. So let me bring that and line it up there. So -3x plus 4y equals 14. Okay, so now raise your hand. What's going to eliminate the x's or the y's? The y's will eliminate. So it looks like I'm going to use addition here. So I'll add these here. And I'm left with, this cancels out, 5x equals 10. So x must equal 2. So now I'm going to backstub it into, we'll go back into the first one here. So when I backstub it in there, can someone tell me what you're left with? Yep, it's 8 times 2 minus 4y equals -4. So that gives me 16 minus 4y, and then minus 16, -20. And so can someone tell me what y is equal to? +5. And as a coordinate, how would you write it? 2, 5. Perfect. So again, they don't always line up this nicely. These examples do. In the next sections, we'll learn how to multiply or divide them, either one or both of them, so that you kind of get them to line up like that. So down here, you have 2 questions to try. If you could try them on your own, I'll set the timer for like 3 minutes, and then I'll let you get with the partner to check your answers. All right. Could someone tell me what you got for number 19? Yep, 5, 4, 5, 4. So if you look at my work here, did I say 19 for the first one? I don't know where I got 19. So you use addition. You're left with 3x equals 15. Divide each side by 3. X equals 5. Back sub it in here. 30 minus 4y equals 14. Minus 14, you get minus 30. You get -16 divided by -4 is 4. All right, I'm going to spin the wheel on the handy dandy spinner and see who will be lucky enough to show me the second example where you have to rearrange.